So let us start the another theory chapter under the autoquads, particularly the decarboxylated amine autoquads, serotonin. Serotonin is also known as 5-hydroxytryptamine, and because the highest concentration is found in enterochromophene like cell or enterochromophene cell in gastrointestinal tract. So based upon the name is enteramine, means amine of intestine or gut. And we are also calling it serotonin. So why the name is serotonin? Because it is the component of serum and producing the constriction of the blood vessel. That is why the name is serotonin. We are also going to discuss the 5-HT agonist as well as the 5-HT antagonist. So let us start the 5-HT. As we discussed, the 5-HT is kept under the classification of decarboxylated amine autoquad. Means कि autoquad is amine, and from this autoquad carboxyl group removed. This is an autoquad as well as a neurotransmitter, I mean 5-HT. 5-HT perform various physiological and also participate in various physio or pathophysiological function like migraine, like psychosis, like GI disorders, sleep disorders, and many more physiological function is associated with the 5-HT as a autoquad as well as a neurotransmitter. Regarding the presence of 5-HT is concerned, 5-HT is found in high concentration in enterochromophene cells that present throughout the GI tract, in the storage granule, also in the platelets, and also in the central nervous system, that is CNS. Regarding the physiological function is concerned, that we have mentioned many physiological functions are regulated by 5-HT. Amongst that, 5-HT act on the smooth muscle of cardiovascular system as well as the gastrointestinal tract, and therefore it produces vascular vasoconstriction and contraction of the smooth muscle of the GI tract. It also participates in the platelet aggregation while clotting. So when the clotting occurs, the 5-HT get released, and therefore it is responsible for platelet aggregation to form a clot. Regarding the receptor of 5-HT is concerned, the 5-HT receptors are kept in 7 classes or 7 families from 1 to 7, that is 5-HT1, 5-HT2, 5-HT3, 4, 5, 6, 7. When you are going to see all the classes or family of the 5-HT receptor, you will find all the receptor are G protein couple receptor except 5-HT3 receptor. 5-HT3 receptor is ligand gated cation channel, or you can say ion channel, particularly the sodium and potassium ion, and these all 7 classes are subdivided into receptors, and the number are 14 in number. 5-HT, while the 5-HT3 receptor is not subdivided. Amongst the agonist and antagonist is concerned, they are going to act on the various receptor of the 5-HT that we already discussed. The one most important point is that in GPCR receptor, they are mainly mediated through the adenyl cyclase. Mediated through adenyl cyclase. However, among all GPCR, 5-HT2 subtype is rather concerned to the enzyme phospholipase C beta. This adenyl cyclase is mediated through the protein GS and GI. GS and GI. However, this PLC is mediated through protein GQ. So this is very, very important and interesting. So for your information, how this molecular function is going to perform by 5-HT. 5-HT is going to attach with the receptor, and thereafter once 5-HT get attached with the receptor, they get activated the receptor, and if this is the GPCR receptor, then either it get activated or activated GQ protein, or either it get activated and inhibited GIS and GI protein, and therefore it get activate the enzyme adenyl cyclase or phospholipase C. So when it get activated adenyl cyclase, ATP get converted into cyclic AMP, and therefore this cyclic AMP is going to produce the cellular function. In case of phospholipase, this phospholipase convert PIP2, and this PIP2 is get PIP2 get converted into two components, that is the DAG and IP3. And this DAG and IP3 is going to give the second messenger to produce the physiological function. So this is about in nutshell the silent feature concerned to the 5-HT. Now we have to go one more important point with the 5-HT, that is also an important silent feature, is that 5-HT receptor subtype are the largest amongst the other neurotransmitter family. So this is very, very important. Now we have to go through the history of the 5-HT. The first scientist was in about 1930s, Urs Palmer. He studied about the distribution of 5-HT, and for that he stained the different cell with the stain that is staining the indole group, and therefore Urs Palmer found that regarding the distribution of 5-HT, found that highest concentration of 5-HT distribution is found in the gastrointestinal tract, thereafter platelet, and finally CNS. So the peak concentration or highest concentration of the 5-HT distribution is in GI tract, followed by platelets and the central nervous system. So this is very, very important. Later on, one more scientist along with the colleagues, Page and the colleagues, who isolated the 5-HT as well as chemically characterized the 5-HT. So Page and its colleagues isolated the 5-HT and also chemically characterized the 5-HT and cited that the 5-HT is a vasoconstrictor substance, and he was studying or isolated from the clotting blood That means कि platelet get aggregated, and therefore on the basis of the isolation from the clotting blood that the found the platelets there, the name he named the compound serotonin. The serotonin or 5-HT. Serotonin he named. So what is the meaning of serotonin? Serotonin means it is isolated from the serum, source is serum, and possessing the constriction action, that is tonin, serotonin. And he found that the compound he isolated, that is identical to the indole isolated by Urs Palmer. So this is about the history concerned to the 5-HT. Now we have to go through the chemistry and the source of the 5-HT. Regarding chemistry is concerned, you have to go through the structure. So this whole ring is called indole ring. And with the indole ring, hydroxy group is present. So the name of this indole is 5-hydroxy indole. Why? Because this is present on the 5 position. So 5 indole, 5-hydroxy indole. Now this is the ethyl group. So this is methane, that is alpha 1, and this is the beta 1. So this alpha and beta ethyl, on beta 1 amine group is attached. So the name of this from here to here is 3 beta amino ethyl. So total name is 3 beta amino 3 beta amino ethyl hydroxy 5-hydroxy indole is the chemical name of the 5-HT. So this is all about the chemistry of the 5-HT, and its presence is concerned, it is presence it present in most of the species like vertebrae, like tunicates, like mollusks, like arthropods, like coelenterate, like fruits, like nuts, like venom. So its presence is concerned with many species that I have mentioned. Now we have to go through the synthesis as well as the metabolism of the 5-HT. Now we have to go through the synthesis and metabolism of the 5-HT. So 5-HT, we have to go through the first the synthesis process. So within the cell, particularly the CNS, and enterochromaffin cell in which 5-HT gets synthesized in these two cells. So how this is going to get synthesized within the cell? So within the cell, amino acid tryptophan get converted into 5-hydroxytryptophan. So this tryptophan get converted into 5-hydroxytryptophan. So how this 5-hydroxytryptophan get formed? That is means ki this is the addition of hydroxyl group. So the name of the enzyme that participating in formation of 5-hydroxytryptophan is hydroxylase enzyme. So what is the function of hydroxylase enzyme? To form the hydroxylation. So what is hydroxylation? Addition of hydroxyl group. So tryptophan with the presence of enzyme tryptophan hydroxylase TPH, that is particularly for the enterochromaffin cells. The name of the enzyme is tryptophan hydroxylase 1. They form the first product of the tryptophan. We call it 5-hydroxytryptophan, and this enzyme is a rate limiting enzyme. So this is very important, because this is two-step formation of the 5-HT. In second step, they are going to form the 5-HT. So in second step, because this autocoid belongs to the decarboxylase amine autocoid, the decarboxylation occur. So decarboxylation occur in presence of enzyme. We call it decarboxylase enzyme. So decarboxylation means ki it is the removing of the carboxyl group from the 5-hydroxy tryptophan, and therefore this is going to form the final product, the 5-HT. So name of this 5-HT chemically is 5-hydroxytryptamine. So the name of this is 5-hydroxytryptamine, and the name of the second enzyme is decarboxylase. The full name of this decarboxylase is the name of the enzyme is L aromatic acid L aromatic amine acid decarboxylase, or simply decarboxylase enzyme is participating to form the 5-HT. So this is 5-HT or serotonin or enteramine. So this is 5-hydroxytryptamine is formed. Now we have to go through the metabolism of this 5-HT. So this is also the main two pathway that we are going to discuss, only the two pathway of metabolism, the primary pathway of metabolism and alternative pathway of metabolism of the 5-HT. So this is primary pathway of metabolism and another is the alternative pathway of metabolism. In primary pathway of metabolism of 5-HT, to form the final product is 5H 5HIAA. So 5-hydroxy indole acidic acid is the final product of the 5-HT metabolism through the primary or main pathway. In first step, deamination occur, and this deamination occur with the help of enzyme. We are going to call it MAO, monoamine oxidase, and therefore it form 5-hydroxy indole acetaldehyde, 5-hydroxy indole acetaldehyde. And now this acetaldehyde is get converted into the final excretory product that is going to be excreted out through the urine is 5-hydroxy indole acetic acid. In presence of enzyme, we are going to call it, the name of the enzyme is 5, mainly the this may be final product is formed, but the name of the enzyme is 5 aldehyde dehydrogenase, not 5 aldehyde dehydrogenase. So aldehyde dehydrogenase is participating to form the final hydroxyindole acetic acid, or it may be this final through MAO. This is going to form this through this enzyme monoamine oxidase is going to form oxidative deamination, means removing the amine group to form this 5-HAA, and that is going to be excreted out through the urine. So this is about the primary pathway of the excretion of the 5-HIAA. Here very interesting is that this is also synthesized in the brain, and this is also going to be excreted out from the brain. So this excretion through the brain may be halted, may be inhibited, may be nullified by anti-gout drug probenecid. So probenecid is rather going to inhibit the excretion of or export of 5-HIAA from the brain to the excretory excretory route. So this is probenecid. Alternative pathway of excretion is concerned. In case of alternative pathway of excretion, this is also the two-way pathway of synthesis, And in this two-way pathway of alternative pathway of synthesis, it forms the product we call a hormone melatonin. So melatonin hormone is formed through the alternate pathway, and we know that this melatonin is a hormone, and it is present in the pineal gland, and that is participated in the sleep and wake up cycle. Melatonin is maintaining the sleep and wake up cycle, and this is also two-way pathway to get synthesized. In first step, one enzyme is participating, that is going to acetylate this 5-HT. And after the acetylation of this 5-HT, the product is formed that we are going to call it the N-acetyl 5-HT. N-acetyl 5-HT is formed. N-acetyl 5-HT is formed, and this is formed in the presence of the enzyme we call it acetyl enzyme that acetylate this reaction, and the name of the enzyme is the 5-HT N-acetylase, or simply N-acetylase. And in second step, this is going to form mainly the methyl transfer. So the name of the enzyme is hydroxylase O methyl transferase, and therefore this is going to form the hormone melatonin, which is wake up and sleep cycle hormone present in melatonin. So this is all about the metabolism is concerned, and this is written in the word or sentence. So this alternative pathway 5-HT get converted into N-acetyl 5-HT, and this is going to form in melatonin if in presence of acetylase enzyme, in presence of hydroxyl indole O methyl transferase enzyme respectively. And in first step of the metabolism, in presence of monoamine oxidase, the 5 hydroxy indole acetaldehyde form, and thereafter the main excretory product 5 hydroxy indole acetic acid is formed, and that is excreted out through the urine. So this is very very important and important. Now we have to see one very very interesting isoform of the tryptophan hydroxylase, that is TPH2. So what is this TPH2? Is the tryptophan hydroxylase enzyme isoform, and which is specifically present in the brain. So this is very very important and participating in the 5-HT synthesis, because this is the rate limiting enzyme. Now we are going to go through more point. We already discussed about the probenec acid. Now we have to go through more point. One important protein, which is a transport protein, we are calling it SERT, S-E-R-T, all in capital, or also called 5-HTT. So what is SERT? SER stands for serotonin, and full name is serotonin uptake transporter protein. So this is very very important. What this transporter is going to do, this is going to nullify or zero the function of 5-HT by reuptake or uptake process. What it means, when the 5-HT get released, the 5-HT is going to perform its local hormone function on the surrounding tissue, and its function get be destroyed, degenerated, nullified either through the metabolism that we have mentioned, or either through the reuptake or uptake within the cell. So this uptake of the 5-HT is performed by a transport protein. We are going to call it SERT, or serotonin uptake transporter protein. So this is participating in nullifying the effect of 5-HT by transporting it in the or within the cell. So this is very very important. And this transporter protein function is going to be inhibited by the drug that is called SSRI. SSRI. So what is this SSRI? SSRI is the selective serotonin reuptake inhibitor. SSRI is selective serotonin reuptake inhibitor, which is going to inhibit the transport of serotonin from surrounding the cell to inside the cell by inhibiting the function of SERT protein, and therefore SSRI are used for the therapy of anxiety and depressant as a anxiolytic agent or as a antidepressant agent. So what are the example of SSRI, selective serotonin reuptake inhibitor? This is going to inhibit the transport of 5-HT from surrounding to within the cell and used for the therapy of anxiety, that is anxiolytic agent, and also reducing the depression. So this is antidepressant agent. And the drug are citalopram, sertraline, escitalopram. So these drugs are going to be used for anti-anxiolytic or anti-anxiety drug or antidepressant drug. Now we have to go through the pathophysiological function. So what this SSRI going to do? This is going to inhibit the uptake of 5-HT by blocking the action of SERT protein. So this is very, very important. Metabolism is parallel to non-adrenaline. Now we have to go through the pathophysiological role of 5-HT or physiological role of 5-HT or pathological role of 5-HT. So because this is 5-HT is an autoquad, also a neurotransmitter, it regulates sleep, it regulates mood, it regulates appetite, it regulates pain, it regulates vomition, it regulates temperature, it regulates sexual behavior, it regulates thoughts, it regulates cognitive behavior. So 5-HT as a neurotransmitter, as a autoquad performing various function and very, very important, and some more function that we are going to discuss, that 5-HT is participating in the vomition and nausea. So this is very, very important through 5-HT3 receptor. Through 5-HT3 receptor. So when this 5-HT is going to act on the 5-HT3 receptor, this is going to produce nausea and vomition. How this nausea and vomition is going to produce? This cytotoxic drug or chemotherapeutic drug or radiotherapy or some post operation or operation, after operation they are going to stimulate to release the 5-HT, and or this is going to act on 5-HT, and therefore 5-HT is going to act on the 5-HT3 receptor present on particularly the places like the chemotrigger CTZ chemoreceptor trigger zone, or this is present on the nucleus tract solitarius, or this is present in the GI tract. So therefore when these receptor I mean 5-HT3 receptor get stimulated due to the presence of cytotoxic drug, due to radiotherapy, due to operation, they are going to produce the vomition. So this is very, very important. So we are going to block this receptor by inhibiting this receptor by using the antagonist, 5-HT3 receptor antagonist. Also this is also going to participate with the or concerned with the migraine. And also this is concerned to the cardiovascular or smooth muscle function. So when the 5-HT is going to act on the smooth muscle of the cardiovascular system and smooth muscle of the intestinal GI tract, they are going to regulate the smooth muscle constriction as well as the smooth muscle contraction present on the cardiovascular system and present on the GI tract. And if this is present in the this cardiovascular system, they are going to produce the vasoconstriction. And when we are talking about the heart, so this 5-HT is going to be stimulate the heart and produce the positive chronotropic and positive inotropic effect. So this is very, very important. As we already discussed, the 5-HT is also going to participate in clot formation. So clot through platelet aggregation. So 5-HT is going to aggregate the platelet and therefore helping in the clot formation to check the bleeding. So it is act as a hemostasis, and also going to increase the intestinal motility by releasing the enzyme neurotransmitter, not enzyme, by releasing the neurotransmitter acetylcholine neurotransmitter, as well as it is acting on the smooth muscle of the GI tract and increases the contract and give rise to peristaltic movement by contracting it, and therefore it participate in the digestion. And when we are going to use its agonist, this is to be used as a prokinetic. So mainly here in enterochromophene cell, the rate limiting enzyme tryptophan hydroxylase number 1 is present. So this is important. Now we have to go through the last part of the 5-HT, that is the 5-HT3 receptor agonist and 5-HT3 receptor antagonist. That is very, very important, and we are going to discuss one by one. So 5-HT1 receptor, 5-HT2 receptor, 5-HT3 receptor, 5-HT4 receptor, and 5-HT5 to 7 receptor. So as I mentioned, all the receptor of 5-HT are G protein coupled receptor, except 5-HT3 receptor. This is the ligand gated cation channel or ligand gated ion channel. So this is very, very important. Another point that I have mentioned, the enzyme concerned with the 5-HT2 receptor is the name of enzyme is phospholipase C and the name of the protein is GQ. However, other than this, the enzyme is participating is adenyl cyclase. Now we are going to discuss about its subtype of the receptor. Regarding 5-HT1 receptor is concerned, the sub-receptor are 5-HT1A, 5-HT1B, 5-HT1D, the important one. Whereas in case of 5-HT2 receptor subtype are 2A, 2B and 2C. So this is very, very important. Now we have to go through the one by one, its presence, its agonist and its antagonist, that we have to discuss elaborately or in detail, because this have the therapeutic utility. So that is why this is very, very important. Now we have to discuss the first one is, we have to go through the back because the small one we have to move first one. So regarding 5-HT 5 to 7 means 5, 6 and 7 receptor is concerned, they are present in the central nervous system or the brain. Now we have to go through the 5-HT4 receptor, its presence. So 5-HT4 receptor is possessing the therapeutic value. So that is why this is important. So 5-HT4 receptor is present in the GI tract as well as the in CNS. So when 5-HT, a neurotransmitter autoacquired is going to act on the receptor 5-HT4 receptor. Therefore, what this is going to do in the GI tract? In the GI tract, this is going to increase the neurotransmitter secretion acetylcholine as well as the contraction of the smooth muscle of GI tract and increase the GI motility, and therefore it helps in evacuating the bowel or digested food from the GI tract and helps to relieve the constipation. So therefore we are going to use the agonist. So now we are going to discuss about the 5-HT4 receptor agonist. So there are two very important drugs, metoclopramide and cisapride. So these two drugs, metoclopramide and cisapride, are 5-HT4 receptor agonist and used as a prokinetic. So what is the prokinetic? Prokinetics are the drug, the chemical, the agent which enhances the GI tract motility and helps to remove the gases and helps to participate in digesting and evacuating the bowel are called prokinetic. So therefore, these two drugs are coming in this. Now we have to go through the 5-HT3 receptor. That is not a GPCR. It is a ligand-gated cation channel, ligand-gated ion channel. And as we earlier mentioned, this 5-HT3 receptor is present in chemoreceptor trigger zone, is present in nucleus tract solitarius, and when 5-HT is going to act on the 5-HT3 receptor present on the CTZ and NTS, they are these are going to induce the vomission or emesis, or that is also induced by the drug like chemotherapy, cytotoxic drug like radiotherapy, not drug, radiotherapy or operation. These all are going to induce this 5-HT3 receptor at the CTZ, at the NTS, and therefore it produces the vomission. So when we are going to check the vomission, we are going to block this pathway, I mean 5-HT3 receptor antagonist, to use as a anti-emetic drug, anti-emetic, or check the vomission. Also, this is going to induce the parasympathetic neurotransmitter, and therefore it increases the peristaltic that we are already discussed with the 5-HT4. Now we have to go through its agonist and antagonist, that is the 5-HT3 receptor agonist. So when we are talking about the agonist, only one drug is here with the 5-HT3 receptor agonist. Before 5-HT, we have to only put 2-methyl. So the name is 2-methyl-5-HT is the 5-HT3 receptor agonist. Now we have to go through the antagonist. I mean the 5-HT3 receptor antagonist that are to be used for the therapy of vomission, to check the vomission. And the drug that are having the suffix cetron. So odensetron, granisetron, tropisetron, ellocetron. So this receptor, 5-HT3 receptor, is going to be blocked by these drugs, and these drugs are going to be used as an anti-emetic drug. Actually, the emesis caused by that we already discussed by the chemotherapy or radiotherapy or operation. So for this treatment, we are going to use the drug like 5-HT3 receptor antagonist to check the vomission induced by the chemotherapy, induced by radiotherapy, or post-operative that is going to produce the emesis. So we are going to use the odensetron or granisetron or tropisetron. Another drug from the same cetron, ellocetron. Ellocetron is particularly used for vomission caused by irritable bowel disease, IBS. So this is very important. Now we have to go through the two more agonist and antagonist concerned to 5-HT2 and 5-HT1 receptor, agonist and antagonist. Now we have to go through the presence of 5-HT2A receptor, presence of 5-HT2B receptor, presence of 5-HT2C receptor. So 5-HT2 receptor is present in the smooth muscle of the GI tract and also on the blood vessel, and therefore it produces vascular smooth muscle constriction and contraction of the smooth muscle of the GI tract. Also, it is present in the CNS and also responsible for platelet aggregation through 5-HT2 receptor, its presence. Now we have to go through the 5-HT2B receptor. So this 5-HT2B receptor is present in a stomach, particularly the funduc region, and produces the stomach contraction. Last one is the 2C, is present in the choroid plexus in central nervous system, and therefore it participated to increase the cerebrospinal fluid. Now we have to go through the agonist and antagonist of the 5-HT2 receptor. Now we have to go through the agonist. 5-HT2A receptor agonist is very important drug that we are using nowadays as a hallucinogenic agent is lysergic acid diethylamide, that is the LSD, that we are used for not good purpose but for producing hallucinogenic action, and this is going to produce the addiction. So they are going to use by the person, those are the drug addict. So this lysergic acid diethylamide is 2A receptor agonist, and another agonist is 2C receptor agonist. The drug is lorcaserin. So lorcaserin is used as a anti-obesity drug. So this is going to reduce the motapa. So anti-obesity drug 5-HT2 receptor agonist is lorcaserin, is used as a anti-obesity drug, and so it is also going to increase the cerebrospinal fluid. Now go through the antagonist of the 5-HT2A and 2C that we are going to discuss one by one. So here the antagonist, particularly ketenserin, and another is cyproheptadine, is mainly 5-HT2A receptor antagonist, but it is less antagonist on 5-HT2C receptor. So ketenserin is primarily 5-HT2A receptor antagonist, but it is less antagonist on 5-HT2 receptor 2C receptor, and used for the therapy of migraine, depression, schizophrenia, and also this is participating in the platelet. It inhibits the platelet in aggregation, ketenserin. So ketenserin is the very important because used as a drug for the migraine, depression, and schizophrenia. One more drug as antagonist is the methysergide, is a 5-HT2C antagonist. Methysergide. This is also used as a migraine therapy, but as a prophylaxis measure, not as a therapeutic agent. So this is very important. Now we have to go through other antagonist that is particularly used for the therapy of the psychosis. So this is called a typical antipsychotic drug. So in these the drug are acting on mainly 5-HT2A but also on the 2C. 5-HT2C also acting on the 5. This drug is olanzapine, clozapine. So olanzapine and clozapine is acting both on the 5-HT2 and 5-HT2C, A and C, whereas 2A antagonist drug risperidine is mainly or only acting on the 2A receptor as an antagonist, and both are used as a antipsychotic drug. So this is all about 5-HT2 receptor agonist, antagonist, and detail about the 5-HT2. Now we have to go through the last one, 5-HT1 receptor. So this 5-HT1 receptor is mediated here I am going to mention about the 5-HT4. This is going to act through the protein GS, whereas the 5-HT2 is through the GQ, whereas the 5-HT1 is through GI. Means ki this protein is going to inhibit the function of adenyl cyclase, and therefore it decreases the cyclic MP level in the intracellularly. So GI protein is participating. So this is very, very important. So adenyl cyclase is not activated, less cyclic MP is produced, and therefore this is going to perform the function through the 5-HT1 receptor. Now, where these receptor are present, I mean 5-HT1 receptor. 5-HT1 receptor is present in the central nervous system. Mainly, you can say mainly present in the central nervous system. Also in the present in the smooth muscle, particularly the vascular smooth muscle of the cranial region, and causing the constriction. So this is very, very important. Now we have to go through the 5-HT1 receptor agonist, and the receptor subtype we already discussed A, B and D. Here with the 2 is the A, B and C. With the A is the A, B, D mainly. I am talking about the mainly. Now we have to go through the 5-HT1B and 5-HT1D receptor agonist. The suffix is trypton. Trypton. So name of the drug is sumatriptan and naratriptan. These two are the drug. That more drug is also from this trypton group, used for the therapy of migraine, mainly used for the therapy of migraine, and it is acting through the vasoconstriction action. The side effect is this is going to produce chest pain or the heart pain, and this is contraindicated in the ischemic heart disease. We are not going to discuss in detail. Now we have to go through the partial agonist of the 5-HT1 receptor, particularly 1A. So there the suffix is piron. So drug are buspirone, gpirone and ipsapirone. So these three drugs, mainly three drugs, are partial agonists on the 5-HT1 receptor, and these drugs are used as a anti-anxiety drug. The first one agonist, that is the primary agonist, that is having the trypton suffix, and that are used as a migraine therapy, whereas these are using as a anxiolytic drug or anti-anxietic drug that are having suffix piron, buspirone, gpirone, ipsapirone. And now we have to go through the last point about the 5-HT1 receptor antagonist, and that is the ergot alkaloid, that is the ergotamine. Ergotamine is the 5-HT receptor antagonist, but it is also partial agonist. This is very, very important. So this is all about the theory class number 13. In next class we are going to discuss the next autoquads. That's all.